Ooh, hello YouTube, how are you? Today I'm back with another video on Mastercam tutorial, and I want to talk about the Mastercam to the high-speed Toolpath this time. As you know that the high-speed machining, the high-speed Toolpath is now widely used because they have many advantages. They reduce the machining time a lot. They reduce the tool wear, so increase the tool life. They're also very good for the machine, and so that's why many people uh, want to use this kind of tool pad. And every cam package now they provide a high-speed tool pad. So I think it's very good to show you how to use the high-speed tool pad on your part. And in this video, I will talk about the 2D tool high-speed tool pad. We will talk about the 3D high-speed on another video. Okay, and I'm very appreciated because you follow me and watching my video. I'm not a professional trainer, and my English is not so good. If I don't want to say it's very bad, so I really appreciate it, and I hope you can enjoy my video. And I want to share my knowledge to you. Okay, we come to the main topic today. Here you can see on the screen here our park. This is the theme park with the pin on the top. And let's take a look on the front. You can see the Z0 is set on the top of the park. And this park has many features I can use to describe how the high-speed Toolpath work. Okay, the first thing we need to do is select a machine for the job. Like in every other video, I will select a 3-axis vertical machining center. And the next, we will create a stock, define the material for the part. For example, this is an aluminum alloy part, so I will create a stock for this. I will cut it from a solid block of aluminum. Okay, I haven't drawn any boundary to define the contour, so I will use a function of Mastercam to create a boundary. Okay, at first you select it to 2D first, and you go to the create menu and you select the bounding box function here. Okay, click on this, and Mastercam will ask you to select the entities, and you select the part and click enter. In the 2D mode, the Mastercam will just create a boundary chain. It's not create a boundary box. If you want to create a boundary box, you need to switch to the 3D mode. Okay, and there's no need in this case. You can see when we click the part, Mastercam will pick the length and the width of the stock for you. If you want to extend a little bit for the material, you can add to this value. For example, I can add 0.25 for the length and 0.25 for the width. Okay, and remember to click on line and arc so Mastercam will draw the boundary for you. If you want to draw the center point of the stock, remember to click on this. Okay, everything is done now. We click OK. So you can see we have a boundary here, so we can use this to set up the stock. Okay, and now move to the stock setup right here, and select corner. I pick this corner and this corner. Alright, and you can see the length 10.25 and the width 5.25. I don't know how to read it in English correctly. How we can understand. Okay, and the Z for the height of stock is 1.5. Okay, I will leave no material on the top. For example, this material, this stock had been facing before. I just want to keep focus on the high-speed toolpath only, so I skip other sub toolpath. Okay. Oh, I forgot to display the stock. You can click display here to see what the stock look like. Yes, that's our stock. All right. No need to display it. Just keep it high. All right. Ooh, what we do next? I will talk a little bit about Mastercam high-speed 2D high-speed toolpath. And you can find the high-speed toolpath on the toolpath menu and on the high-speed 2D high-speed here. You can see in the Mastercam XA and Mastercam X9, Mastercam 2017, the dynamic toolpath just only the few things like this, and in the reverse version like X7, X6, X5, Mastercam has split the dynamic, the high-speed toolpath in many subtype of toolpath. But the newer version, you just can see the dynamic mirror, the dynamic contour, area mirror, pure mirror, and plane mirror. There are 5 type of 2D high-speed toolpath. I will talk X type about X type here. First, we will talk about the dynamic mirror. It's the very popular and mostly used to me. This is the mostly used toolpath that mostly use the high-speed toolpath. So you can take note on this. So you can see I define a socket for this type toolpath because I use it every time. Yes, a lot. You have, okay, we begin with the dynamic mirror first. So when we use the dynamic mirror when can be used when you want to remove a lot of material, a lot quantity of material uh, from the part. For example, I want to machine this pin here, this cylinder here. I want to remove the material outside of the part and left this pin. So in this case, I can use the dynamic mirror. Another case is I want to remove the material in these pockets. You can see the round pockets and this pocket and this center pockets. Yes, a lot of material need to remove. So I can select the dynamic mirror here. Please take note that dynamic mirror can also mirror the material from outside, and it can also mirror the material from inside, like a pocket like this. Yes, so I will explain in next case. Okay, and the next toolpath is dynamic contour. Yes, dynamic contour. When we use dynamic contour can be used when you want to okay, it's like the 2D contour, but it combined with the high speed function. Okay, for example, you need to do a contour milling to create outside shape of the part. But for normal 2D contour, when the tool engage on this area, you can see this area, and this area, the tool will burrow, and this is not good for the tool because there's a lot of material in this area as this and in this area, so this is not good for the tool. That's when we use the dynamic contour. Okay, dynamic contour can be used when we want to remove a little of material, very least material, but there's some area the material increase. You have a lot of material, just some area, so you can use dynamic contour in this case. For this outside contour, I can use the dynamic mill also, not only the dynamic contour. So I will explain you later. Okay, we will start with the dynamic mill and dynamic contour first. And when we have time, I will talk about the area mill, pier mill, and plane mill. This is not important. This just keep in take note. And this toolpath and this toolpath they use very often. Okay. First, I will talk about the dynamic mill toolpath. As I told you before, the dynamic mill toolpath can be used to remove the material from the outside, but also remove the material from inside, like pocket like this. Okay. For the first example, I will use the dynamic mill to remove the material from the outside, and I will leave this pin. All right. You select the toolpath here and select 2D high speed, and then pick on the dynamic mill. Ping. All right. Set a name for the NC5. Ping. So you can see that the chain option window open. There are few parameter you need to take a look on this. In the first, you will see the machining region. Yes, this allows us to select the area we need to machine. Okay, for this case, I want to mill the outside material and to leave this pin. So my machining region, I can select the this chain is the boundary of the stock. Yes, because I start from a rectangular block, so I select the chain as my machining region. Okay, and you can see next that's the machining region strategy. You can select the tool can cut from inside or cut from outside. In this case, I want to remove the material outside the pin, so the tool of course cut from the outside. The tool will cut from outside to inside. And for pocket like this, we will change this strategy to stay inside. Yes, we use this later, but in the first example, to machine the pin, I will select from outside this suitable option. Okay, and we got the next open chain extend to stock. Uh, you can temporarily skip it because we don't use it in this example. We talk about this later. Okay, next avoidance region. So what this mean? Avoidance region let you define the region you want to leave. That's the region you don't want to machine, you don't want to cut off. And sure, in this case, I can select the pin, a chain to define the pin here. Okay, I got you can select and change to solid mode and select this chain. Okay, so you can see I got the machining region, I got the avoidance region. You can see other parameter like air region, containment region, and entry chain. We talk about them later. And this first example, I just use the machining region and avoidance region. Okay, and remember to select the machine region strategy from outside. No need any entry chain. Okay, and then click OK. So after we select the tool path type, next to select a tool, a cutting tool for the job. Okay, let's start with a point half inch mill. Where is it? Yes, here it is. Half an inch mill. Okay. The feed rate, yes, very fast because it's a high speed tool pad. The feed rate is very high. Depend on your material, cutting material, the tooling material, but it's very high. For example, we cut that 100 inch per minute. Okay, plung rate. For example, 40. Then go at 150, 200. It depend on your machine, material, and your cutting tool. Okay. For example, 10,000. Oh no, no need to 10,000. 8,000, for example. Then we move to the holder, select the holder for the job. Oh, the tool need quite long. No need. Alright. And we move to the cut parameter window. In this window, you can see you have some parameters. I will explain one by one. Yes, it take time, but I will explain one by one. So this window, you can select the cutting method. You can select the clamp milling, conventional milling, or zigzag milling. But most of case we use the clamp milling to uh, uh, reduce the tool wear because the conventional milling is not good for the tool. Yes, the tip compensation. Okay, you can select the tip because this is a flat end mill. Approach distance. Yes, this is distance. You can see here. Mastercam will show you on the picture what is the approach distance. Yes, you can put that 0.5, and you can select the position where the tool engage the part. Just estimate position. You can have bottom left, bottom center, bottom right, mid right, top center, top left, and mid left. Oh my God, a lot of position you can select. Okay, and in the new version of Mastercam, Mastercam provide the first path offset parameter that's in case you have a stock, but the operator had cut it larger than the size in the drawing. For example, they cut. I have a stock at 10 inch and 5 inches, and the operator cut at 11 inch and 6 inches. So that's not good for the tool. So you can input here the first part offset to make the tool path more safe. Okay, for example, I will input first part offset from the stock. Okay, the first part is we can do a line cut then to make sure nothing wrong with the material. Okay, and the first part offset feed reduction. Yes, you can reduce the feed rate. For example, you cut the full part with the feed rate of 100 inches per minute. And in the first part, you can reduce the feed rate to make the tool paths safer. Okay, you can reduce at 50% or even 75% normal speed. Okay, and next the step over, like in 2D normal tool path, you have select a step over. In the high speed machining, the step over is normally run from 5 to 25 or even more, depend on the material and the depth of cut. I normally use 15% of tool diameter for aluminum, or even more if you want, and a minimum tool path radius. So Mastercam will explain it here. What is it? Yes, this is the minimum tool path radius on the Toolpath, if you input a small value, the tool will engage can move to the small corner like this, but the Toolpath will not smooth when run at high speed. So if you input a large value here, the Toolpath will smoother, but the tool cannot move into some small corner. Yes, you can consider to select a right value here in the mean Toolpath radius. Okay, and one very important parameter, and I don't know if I can explain it clearly because my bad English. Just want to explain it how you can understand it, or if you don't know what is it and you don't know what I'm talking about, you can go to the help menu here and you go to the field definition and you click on the value you don't understand. For example, gap size, what the hell is gap size, what's the distance, Mastercam will tell you what is it. So if I can tell you, okay. All right, and so what is the gap size for a Toolpath? The tool, for example, with this part on the picture, the tool can machine this region and it can machine this region. When the tool uh, after machine this region, the tool move to this region to machine. If the distance from this region to this region uh, smaller than the gap size, the tool as you can see here, if the motion that the distance between this region to this region to another region smaller than the gap size, the tool will do a back motion. Yes, a feedback motion, that's go and move back. If the motion is smaller than the gap size, you can define the gap size here by the percent of tool diameter or by distance. For example, I define the gap size is 5 inches, and if the distance from this region to this region sorry, smaller than 5 inches, the tool will not retract, it will go travel I don't know how to explain that, fast travel but not retract the tool. And when the tool go back from this region to another region, you can is the do not cut into the material. You can input the back feed rate for the tool, for example 200 inches per minute, because this is just the, the comeback motion, so it not cut the material. You can move it faster than you cut the material, okay. And if you don't want to the bottom of the tool contact with the part during the back motion, you can input the micro lift distance here to avoid to avoid the button of the tool contact the part during the back motion. Yes, that can reduce the tool wear and reduce the heat transfer to the tool during machining. All right, indicate. Okay, I can use. I don't want to use the micro lift distance, so I can input it 0. And if the motion greater than the graph size, you can let Mastercam do the retract motion. Yeah, you can see here. Oh, where is it? Yeah, you can see the retract motion. If the distance from here to here greater than the gap size, Mastercam can for the tool to retract. If you don't want to retract the tool, you can select the never option here. Or if you want to retract the tool when collision, to avoid collision to a boundary, you can select this option, and you can select other option here. Yeah, or when exceeding a distance, when exceeding gap size, the tool will retract. Yeah, they say you select the condition for the retract motion. If you don't want to end, you don't want any retract, just set it never, and the tool will keep down. It's never retract during cutting. Okay, so you can see here, cut auto optimization. Yeah. To know what it is, please click on the help button. Mastercam will explain this clearly. I can explain clearly with my English. Oh, sorry. Oh, where is it? Yeah, here, see. Mastercam will explain it for you very, very clearly. Alright. And yeah, you can select the stock to leave on the wall. That means how much material you want to leave on the wall. In this case, the pin I want to leave. Okay, leave 401 and leave no material on the floor. Okay, so we are done with the cut parameter. Oh, I'm really tired. Want to? Sorry, I need to drink a little bit of water. Oh, it's great. Okay, and if you want to cut in multiple depth because the tool fluid length is not long enough, you can select depth cut. But in this case, my tool is long enough. It's at enough cutting edge, enough cutting fluid, so I don't use the depth cut option. Entry motion, because in this the first example the tool engage from outside the part, so the entry motion can skip. In this case you can select, you can see that it's helix, but just it's just effective when we cut from the inside, like we cut pocket like this. So when we cut the inside, from the inside we need the entry motion, but when we cut from the outside this had no meaning. Alright, rest material. Okay, rest material I will talk later. If you have another toolpath before to rough cut the part, and this high speed toolpath just do the rest cutting the remain material, you can pick on this option, but we don't use this because this is the first our operation, so we don't have the rest material. Okay. We move next to the linking parameter. So like in other 2D toolpath, you also need to select the depth to cut. Okay, I can pick this point here. Yes, the depth is -1 inch, and the type of stock 0. The feed plan, you can input the feed plan, for example 0.5 inch. Okay, we almost done with the first example, and click OK and wait. Mastercam will calculate the toolpath. You can see this symbol. While Mastercam calculating, you can do other tasks. Alright, this look beautiful, right? Like look like high speed, right? Yeah, you see it a lot on YouTube. Toolpath like this. Ooh, let's do the back gloss. Ooh, yeah, the tool move from the outside and it cut to the inside. You can see the step over is keep constantly as much as possible. Yeah, so the tool load is constantly also. That's pretty good for the tool. Yeah, you can see the tool does not retract, doesn't retract because we don't let it retract. Yeah, you can see. Ooh. Okay, but look at this. The the tool pad is very heavy, very large in size. You can see 2,504 kilobyte. Oh, that's not good for our machine. If you want to reduce this size, I will record it in step by step. You can see the tool it go in a small motion, small motion like this. Yes, one motion is one G code line. So if you put this code into your old machine, it can run smoothly. It will run like my grandfather. Okay, so we need to reduce the size of the NC file here. You can do this by click on parameter, go to the R filter and tolerance. You increase this total tolerance to for example 5, then click on line R filtering setting. Move this slide to about 50 and 50, and this will create the arc instead of create multiple small line, and it will reduce the code a lot. Yeah, you can see before we tweak it is like this, more than 2000 kilobyte, and we generate the toolpath. You can see what different. Hmm. Let's wait a minute. Yes, it's done. You can see. Wow, 123 kilobyte. Yes, it reduced a lot. You know what? Why we use that? Because this just a roughing operation, and when you increase the tolerance here, it's not only does not affect the finished part because it's just a roughing operation, so you can increase the tolerance here. But we have a very small size code. You can see, yeah, the tool X motion lift. Yeah, you can see. Yes, it not go in small motion. The tool is smoother now. Yeah, this go very smooth. Every step the tool move a long travel. Yes. And let's verify it. Boom. Wait a minute, my computer is not strong enough. Ooh. Okay, be patient. Be patient. Okay, verify the toolpath. And the first toolpath is the dynamic mirror with what call it from outside strategy. That means the tool will cut the part from the outside. Yes, when we cut from outside to inside. I reduce the speed a little bit. Okay, and run it. You can see. Yes, it runs like a champ. This is the high speed toolpath, like on the video you see on YouTube. Yeah, you can see that we define the machining region, that's our stock boundary, and avoidance region, that's our pin here. And when calculate Mastercam, we cut the material in the machining region, and leave the material in the avoidance region. So we got park here. Oh, very nice. Yes, and this is our park. This is our park after the first operation, the first high speed operation. Yes, that's the high speed dynamic mill with the uh, from outside strategy. Yes, you can see here. Mastercam will explain it here from the outside, so you can cut part like this, cut the material from the outside. And for the pocket, I will use other strategy that stay inside. Oh, for 35 minutes past, I will see you back in another video. Time over now. See you in the next video. I will show you more on 2D high-speed toolpath. Goodbye. Thank you for watching. Bye bye.